mentalizing. Researchers believe it as a characteristic of us as human beings, something that allows us to see ourselves from the outside and others from the inside. Mentalizing is what allows us to read the minds of others, but also to read our own minds. This contributes to the construction of a sense of coherence with respect to oneself and to others who act in the world. Neuroscience today gives us reasons to believe that social cognition itself is a special form of action, a mirrored action which concerns our own bodies. This is why mentalization and mirror neurons are fundamental in building our sense of self and in learning social skills. Balance. Psychological imbalances in the dimensions of mentalization can cause many types of mental disorders. It can cause personality disorders. It can create great difficulties in social relationships and in the perception of others, but also in the perception of ourselves. Can we teach a machine something so much human as mentalization? Can an AI read minds and empathize like a person? What could happen if a machine should not be able to learn to stay with others, to correspond correctly? These are the main questions that the work Should I Smile attempts to investigate. The project Should I Smile consists today in 3 images. These images were not painted or composed in a traditional way with a brush or with a collage, for example. They are the result of outputs generated by the interaction between 2 brains and a generative AI using electroencephalogram. Joint memories, the first of the 3 images, contains a collection of frames extracted from 2 interactive installations and preserved as joint memories. It might seem strange, it might even look familiar. For us humans, joint memories are almost always artificial memories, preserved with technological devices or with analogical and paper artifacts. These memories, stored outside our minds in so many different common ways, are especially important for a sense of belonging and meaningful connections. These memories arise from the interaction between 2 human brains and a machine that tries to interpret their signals. The remaining 2 images, not a Rorschach and 3 brains, 1 mind, contain single frames selected to represent each of the installations themselves. The video produced by each installation was inserted into a digital envelope as if it were a physical memory to be preserved. The project was carried out in this way. An infrared camera allows the AI to see people in front of it. The software returns a different image, not only mirrored but modified and animated through a sort of subjective filter of the algorithm. Sometimes it can appear with a non-human shape, like a stain or as a set of separate images. The pose does not correspond entirely to that observed. The perceived effect is that of finding yourself in front of a strange person, while recognizing your own presence represented by that strange animated shadow. The style and elements with which the AI generates the image vary based on the data obtained in real time via electroencephalogram, EEG. Our presence in space and our EEG signals influence the algorithm, which in turn, by interacting, will influence our own thoughts, establishing an interactive dyad. A first installation requires the presence of only 1 person. A second installation instead requires 2 people, 2 brains, who together will influence the generation of the image in the same way electroencephalogram and presence in the visual field. But with a difference in use of EEG signals, 1 person will specifically send the frequencies typically associated with relaxation. The second will send electroencephalogram, non-visual data of facial expressions, allowing the algorithm to interpret them as emotions. Like us humans, this AI makes many mistakes, and this can cause errors in matching and corresponding the emotions of the human present near to it. In the installation made with 2 human brains thinking, the background for the generation of the image was influenced both by the infrared camera and by some EEG data, such as the raw tracings and the 3D simulation of a brain, in real time, then repositioned above the generated image, partially visible at the top right and on the left side of the images. AI generates images interpretations based on the environmental influence it has received, just as happens in human brains. The environmental influence derives from the real places that the artist frequented. The dataset in fact contains images classified on the basis of hedonic and activation values, just as happens in neuroscience studies on the perception of images and the emotions that they can cause. These were the experimental outputs carried out as part of this project. Should I smile?